Hi guys, in this video we're going to look at another type of substitution reaction in our series of videos looking at types of organic reaction, and here we've got a reaction called a nucleophilic acyl substitution. And there's a series of compounds which can undergo nucleophilic acyl substitution reactions. These often are called nucleophilic addition-elimination reactions as well, but the net result is a substitution because we have one atom or group of atoms there which is substituted for another. Again, in this case, this Y needs to be a good leaving group or can be converted into a good leaving group. So one of the two. So Y has to be a good leaving group or can be converted into a good leaving group. So type of species which can undergo these acyl substitution reactions, well, let's have a look at them and then we'll maybe look at a mechanism. So we have, for example, where Y could be a chlorine, and again you can see this chlorine is a good leaving group. This chlorine can leave the chloride ion, and if you look at the video that we said on an early video on substitution reactions, this chloride ion is a very good leaving group. Other examples that can undergo these reactions would be anhydrides. We call them acid anhydrides, where we've got in this case, all this is my leaving group. And again, this is basically a carboxylate ion, and that is a good leaving group. So what we've got there is our leaving group is a RCOO minus, and this is a weak base. Again, if we have a look, this here is my acid, and it would have a relatively low pK, usually a pK of around 4 to 5. So this means that this group is a good leaving group. Okay, other type of compounds which could undergo these acyl substitutions would be, for example, carboxylic acids. OH is not a good leaving group. It's not a great leaving group. But again, as we said, this can be converted into a better one. So even though OH is not a leaving group, it can be converted into a good leaving group, such as water. So water is a good leaving group. Other ones would be, again, esters would be another example. Again, not a great leaving group, an OR. Remember, R is an alkyl group, not a good leaving group, but again can be converted into a good leaving group by adding hydrogen ions. So this would leave potentially as an alcohol, a neutral molecule. This would leave potentially as H2O. So yes, Y has to be a good leaving group, or this can be converted into a good leaving group. So there'll be nucleophilic acyl substitution reactions, and again, there is videos on my channel which show the mechanism of this reaction, and the mechanism of this reaction is kind of identical. Again, if you want to look at the mechanisms of the reactions of esters and carboxylic acids, you need to look at another video on my channel. So that is another type of substitution. Another type of substitution is benzene rings. If we want to replace, for example, a hydrogen, the benzene ring with another group, we need to do something called an electrophilic substitution. So this here is an electrophile now. So what we have here is let's have a look at the mechanism why this undergoes electrophilic substitution. What we've got here is the benzene ring, and again, if you want to know about the chemistry of benzene, look at my video on structure of benzene. This here has got a relatively stable, delocalized electrons, delocalized stability. So it's going to want to react in order to retain this stability, and it's going to react with an electrophile, and electrophiles are electron deficient species. This can be a delta plus or it can be a full plus. So what we can say now mechanistically is a pair of electrons from the delocalized ring network can attack this. So what we've got here is this region of high electron density above and below the plane of the ring, and 2 electrons can be used to attack an electrophile. The resulting product formed will be as follows. So what we've done is we've kind of broken this bond here. So what we get now is this delocalized ring now is a partial delocalized. So in fact this little horseshoe here represents 4 delocalized electrons in the ring, and we've now formed a new carbon electrophile bond. And it's going to react to retain this delocalized ring network. So the pair of electrons that are in this CH bond are going to then go back and reform the 6 electrons in the ring. And that there is going to give us our product. And that is, we'll call that an electrophilic substitution. And this E here could be a variety of different things, like an NO2 plus ion, and what we call an acylium ion, an alkyl ion like an ethyl ion, ethyl cation. So that's an electrophilic substitution. So that covers the different types of substitution reactions you may come across. We've looked at, in the first video, at nucleophilic substitution, free radical substitution. We've got this nucleophilic acyl substitution, and we've looked at electrophilic substitution.